Okay, exercise 2.2 problem 19. Let's read the problem. If a square, b square, c square are in AP, then show that 1 by b plus c, 1 by c plus a and 1 by a plus b will be in AP. Very similar problem, but only thing is that it becomes a little more complicated. Anyway, we will start marking it. A square, b square, c square are in AP. What does it mean? So b square minus a square, t2 minus t1 equal to t3 minus t2, c square minus b square. And if you want to show that these are in AP, then this minus this must be equal to this minus this. So as we have done in the previous problem, start here, first start here and derive that equation or condition which we can use it for proving. Then start here, this minus this equal to this minus this, simplify that equation and it will get reduced to this equation. That's how we need to do. Okay. So given a square, b square, c square are in AP, we need to calculate that this is in AP, which means this minus this equal to this minus this. That's what we need to prove. Okay. This is the formula which we use. Whenever things are in AP, t2 minus t1 will be equal to t3 minus t2. Okay, so using that formula, and for the first series, a square, b square, c square, we are getting b square minus a square equal to c square minus b square. This equation is true because they told that these three are in AP. Fine. Now apply the same here. Let's assume that this is an AP. So what will happen? This minus this, that is 1 plus c plus a minus 1 by b plus c will be equal to 1 by a plus b minus 1 by c plus a. So this is the equation. Now you simplify, take LCM for LHS and RHS and simplify it, then you will get this equation. If you get this equation, we know that this is true. If that is true, then this is true. If this equation is true, then this is an AP series. That is how you need to prove. Let me repeat. We know this is an AP. If this is an AP, we know we will get this condition using this method, that is t2 minus t1 equal to t3 minus t2. We will get this. Okay, now we are asked to prove that these three are in AP. If let's assume they are in AP. If they are AP, what will happen? This minus this will be equal to this minus this. That's what you have written here. Now you simplify this, take LCM, simplify it. If you simplify, you will get this equation. If you get this equation, we know that this is true, then this is also true. This is true, then these three terms are in AP. Okay. So that's what is told in step 3 and step 4. Okay, now let's work it out for you. A square, b square, c square are in AP. So b square, that is t2 minus t1 equal to t3 minus t2. So b square minus a square, that is t2 minus t1 equal to t3 minus t2, c square minus b square. Okay, this is an equation which will keep, this is true, right? Now let's assume these are the three terms. Let's assume that they are in AP, which means this minus this, 1 by c plus a minus 1 by b plus c equal to t3 minus t2, that is 1 by a plus b minus 1 by c plus a. Now take LCM for LHS and RHS. So LCM for these two is a product of these two. So c plus a and b plus c. C plus a will cancel this, it will go b plus c. So b plus c into 1 is b plus c. Then you put a minus sign here. B plus c will go c plus a times. So b plus c into 1. I'm sorry, b plus c will go c plus a. This will cancel, it will go c plus a times. So c plus a into 1 is c plus a. Similarly, a plus b will go, I'll take an LCM. LCM is a plus b into c plus a. So a plus b will go c plus a times. C plus a into 1 is c plus a. And c plus a it will cancel off this. So you will get a plus b. So a plus b into 1 is a plus b. Now you keep all these things here and say expand your numerator. It will become b plus c, open the bracket, it will become minus c minus a. Okay. Similarly, here also on the RHS, c plus a minus b. We now look at it. This plus c and minus c will get cancelled. Plus a and minus a will get cancelled. So you will get it as b minus a divided by this equal to c minus b divided by this. That's what we have written here. But if you carefully look at it, c plus a is common in both the both LHS and RHS, so we can cancel this off. Okay, that's what you're doing. So I've carried forward the same step here for easy continuity. Okay, so this c plus a and c plus a is common both sides, so we can cancel it. So it will become b minus a divided by b plus c. That's what is written here, and c minus b divided by a plus b. Now what you can do is that you can cross multiply. That is b minus a into, instead of writing it a plus b, write it as b plus a. Okay, so b plus a into b minus a will be equal to, this is c plus b into c minus b. I'm writing it this way basically to use this formula, that's all. A plus b into a minus b equal to a square minus b square. We are not doing any change. 2 plus 3 is also equal to 3 plus 2. It's the same, right? So instead of writing it as a plus b, we are writing it as b plus a. So b plus a into b minus a, which is LHS, equal to, okay, c plus b into c minus b. This is in the form of a plus b into a minus b. So this becomes b square minus a square. And this again is in the form of a plus b into a minus b. So this becomes c square minus b square. What is this equation? Let's go back. That is this equation. We know this is true, right? If that is true, this is true. And then if this is true, then all these conditions got derived thinking that these three are in AP. So since that condition is true, these three are in AP. Okay? So this is how we need to do. Thus 1 by b plus c by 1 by c plus a and 1 by a plus b equal to is an AP. Okay, let me repeat the same condition in all the problems. They have given one series and they say that that is an AP, and they are asked to show another series, 3 or 4 terms, and they are asking us to show that it is an AP. So from the first series, derive some condition, that is using t2 minus t1 equal to t3 minus t2. Okay, and keep that there. Then for the second series, take that to be and assume it to be in AP series and derive the same condition, that is t2 minus t1 equal to t3 minus t2, and derive that condition, simplify it, then you will be able to get the first equation. Okay, that is how both the sums are done. Okay, now what I suggest is go through this video one more time and try to work this problem on your own, and it is more of a simplification issue. Okay, by practice you should be able to get it. Okay, thanks for watching the video.